Hi, super chemists out there in King William. This is Tracy Fulks live talking to you about our notes from class on day one. So on day one, you were given these fantastic notes. It was the first 3 slides of the math unit, which is also on Schoology. And I just want to go over it again with you in case you needed a little extra help. So the first thing we talked about was scientific notation. And scientific notation is really important because it allows us to take really big and really small numbers and communicate them easily. And you've done this in math class. You may have called it exponential notation. So here's the dealy poo-poo when you're doing scientific notation. The first step is to move your decimal until you find a number that's between 1 and 10. So if you're starting with an example that doesn't have a decimal, you'll need to write that in. And then I'm just going to move that decimal over until I get to a number that's between 1 and 10. Boop, 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 boop. All right, so when I stop, I'm at 1.25. That is a number that falls between 1 and 10, so I'm good to go there. The next thing I'm going to do is change my marker because this blue is not dark enough to see well. The next thing I'm going to do is put a times 10 after it. And the exponent that goes with that 10 is the number of times I move the decimal. So in this instance, I moved my decimal 7 times. So this is going to get an exponent of 7. Shazam, I'm done. Now, what happens when you get a number that's a decimal number already? Like the second example, I'm going to move that decimal again until I get a number that falls between 1 and 10. 1, 2, 3, 4. 3.68 is a number that falls between 1 and 10, so I can use that. Then I write my times 10. I moved my decimal 4 times, but this time I moved my decimal to the right-hand side, or I was dealing with a really tiny decimal number. So when you do that, you indicate that it's a really tiny number by making that 4 negative, okay? You should be able to go and put numbers into scientific notation easily. You should also be able to take them out easily. So for instance, 2.3 times 10 to the negative 2. The first thing I notice is this 2 is negative. So this number is going to get smaller. Okay, this is a decimal number. So 1, 2, there's my decimal. What do I put in my little divot there? That's right, I'm going to put some zeros. So because I only have one divot, I just put 1 0. So this number is really that number, okay? On this one, I see that my exponent is positive. That means I'm going to make this number bigger. So when I go to move that decimal, I'm moving it to the right. So 1, 2, 3, okay? I have 2 little divots there. What am I going to put in those divots? Zeros. So this number is really just 5,600, okay? So that's all we did when we talked about significant figures. The third slide on that page, because the first slide was a title slide, the second slide had scientific notation. The third slide dealt with density. And remember we said, where do you go to get your driver's license? You go to the DMV. So that's how we're going to fill out our density pyramid. And it's really cool because look, density is mass over volume. If you're looking for volume, volume is mass over density. And if you're looking for mass, mass is density times volume. There is no density problem that I can give you that the density pyramid cannot help you solve. Okay? So, on your notes paper, because I want to do the one that we did in class so we're all together, it said that 1 milliliter is equal to 1 centimeter cubed. And remember, in the land of science, we use milliliters. In the land of medicine, they use centimeters cubed. That's why if you're watching your shows that are in hospitals, they'll say, I need so many cc's of whatever. And those are cubic centimeters, which are really just milliliters. Now, the example I gave you had a mass of 42. I'll get a different color here. And mass is always in grams, so this was 42 grams, and it had a volume of 102 centimeters cubed. Seeing centimeters cubed does not give me the heebie-jeebies because I know that that is just a milliliter. So when I go to solve this, I'm just going to do a little plug and chug, okay? I see that I'm looking for density. Density is mass over volume. My mass is 42 grams. My volume is 102 milliliters, basically. So I can put this in my calculator as 42 divided by 102, and I'm going to cheat really quick and see what I got. I got 0.41, okay? Got to give it some units, grams per milliliter. So that's the density of my liquid I'm dealing with. Now, when you looked at that problem, I believe it asked you, could it be the same as a saltwater solution with a density of 0.4? No. If this density is 0.41, that is not 0.40. They are not the same substance. Okay? So that concludes your notes from the first day. I hope going over this up here with you again helps you out. I'm sure you guys are going to do amazing with this because you're all super chemists anyway. Take care, and I will see you in class, guys. Have a good one.